How's it, everybody? I hope you're all well. It's Goon here from Goon School, and yeah, we'll be taking a look at the physics chemistry paper 2 from November 2024. So, well, the most recent paper. This is posted for the 2025 matrics. Look, these videos don't usually hit. Like, none of the physics videos that we've made have really hit. My partner, she made the first few, like 30 or 40 physics videos, and actually a tutor who works under the brand, she made the rest. I won't drop names or anything like that. Let's just keep it a secret for now. But yeah, I hope you guys find the video enjoyable. It's pretty much a compilation of all the other videos that we've posted, but everything is coming from November 2024. So yeah, it's 150 marks to be completed in 3 hours. But yeah, we've kind of whacked this video in and around an hour. So yeah, I really hope you guys enjoyed the video. Bye. And, well, not bye, like, you still have to watch it. Okay, love you, bye. Incoming, like, shift to the MCQs. Okay, see you. Goon signing out. Bye.
Hi guys, today we're going to be looking at some multiple choice questions in the physical science paper 2, so the chem paper. Which one of the following compounds has hydrogen bonds between its molecules? So, the one with hydrogen bonds means there's an O bonded to an H, which is usually present in alcohols and things like that. So in this case, if we look at our 4 compounds, the one that has hydrogen bonds between its molecules is compound C, as we can see the OH group over here. Question 1.2. Which of the following is the correct general formula for the carboxylic acids? So, as we know, carboxylic acids always have 2 oxygen atoms. It doesn't matter how many carbon atoms, it always has 2 oxygen atoms, so we can already eliminate B. We then know that carboxylic acids have double the amount of hydrogen atoms that they do carbon atoms, as the two oxygen atoms take up some of the bonds of the carbon atoms. Therefore, our answer would be C, as it has double the amount of carbon atoms, so 2N. Question 1.3. Study the reactions below. Reaction 1 being this one and reaction 2 being this one. Which of the following combinations is the correct IUPAC names of compounds P and Q? So here in reaction 1 we see we have an alcohol and hydrochloric acid is added to it. Well, concentrated hydrochloric acid is used as a catalyst in order to remove a water molecule and form compound P. Therefore, if a water molecule is removed from reaction 1, we will then end up with an alkene. And as we can see from our formula, we have 1, 2, 3, 4 carbon atoms. Therefore, it is butene. And our OH group is on the second carbon. Therefore, when it is removed and forms the H2O, the double bond will be between the second and third carbon. So we will have but2ene. In reaction 2, we take compound P and we go through hydrogenation and get compound Q. So this is when we add an H2 to the compound. And this H2 will cause the double bond to break and form all single bonds. So we will then end up with butane. So our answer would be B. Question 1.4. The potential energy diagram below is for the following hypothetical chemical reaction. Which one of the following combinations of values for the heat of the reaction and the activation energies can be obtained for this reaction? So we can start by looking at the activation energies. So since we start here, the forward activation energy would be this part over here. And for the reverse reaction, our activation energy would be from here to there. Therefore, our reverse activation energy would be bigger than the forward activation energy. And as we can see, the energy of our products are lower than the reactants. Therefore, our delta H is negative. So if we take all of that into consideration, then our answer would be D, as we have a negative delta H and a lower forward activation energy than we do a reverse activation energy. Question 1.5. Initially, an equal number of moles of hydrogen gas and iodine gas are mixed in a closed container. The reaction reaches equilibrium at constant temperature according to the balanced equation. Which one of the following is always true at equilibrium? So, at equilibrium, we know that the forward reaction and the reverse reaction are equal. And we can see that we have 1 mole of H2 and 1 mole of I2. Therefore, the same amount is used of each to produce the 2HI. We can therefore determine that at equilibrium, the concentration of the H2 and the I2 are the same. And this is always true. Question 1.6. Consider the following reaction at equilibrium. Which one of the changes to the reaction conditions below will increase the yield of SO3 gas? So, if we add a catalyst, increase the temperature, or increase the volume of the container at constant temperature, well, actually, just the catalyst and the temperature, those increase the rate of the reaction. However, it does not change the amount of product formed. An increase in the volume of the container at a constant temperature also affects the rate of reaction. However, it doesn't affect the amount of product produced. However, the addition of O2 gas, as we are adding a reactant, will therefore favor the forward reaction and more SO3 will be produced. Therefore, our answer is A. The table below shows the... question 1.7. The table below shows the ionization constants, Ka, for two acids at 25 degrees Celsius. Consider the following statements for these two acids when they have equal concentration at 25 degrees Celsius. So, I, both are weak acids. II, butanoic acid is stronger than ethanoic acid. And III, the butanoic acid solution has a lower concentration of hydronium ions, H3O+, than the ethanoic acid solution. So, since we have a Ka value, which is less than 1, we know that these are both not weak acids. We can see that butanoic acid has a smaller value, a Ka value, than that of ethanoic acid. Therefore, II is true. Butanoic acid is stronger than ethanoic acid. That is my bad. I just read the whole table wrong. So, Ka is the acid constant. So basically, these two are both less than 1, so they're both weak acids. And butanoic acid has a smaller Ka value than ethanoic acid. Therefore, it is a weaker acid than ethanoic acid, causing it to have a lower concentration of hydronium ions. Therefore, our answer is actually B, and 1 and 3 are correct. That is my bad. Question 1.8. Which one of the following pairs of acids and bases, all of the same concentration, react to give the highest pH at the equivalence point in a titration at 25 degrees Celsius? So, if we want the highest pH, we need to have a weak acid reacting with a strong base, as the more basic the solution ends up, the higher the pH. And out of our 4 options, the one with the strong base and a weak acid is D. Question 1.9. A standard galvanic cell is set up as shown below. Which one of the following combinations of the metal used as the cathode and the electron flow direction is correct? So, if we look at our redox reaction table, we would be able to determine whether CD or Ag, or the ions, respectively, which one has a higher oxidizing energy potential and which one has a higher reduction potential. And if we look at that, we can see that the Ag has a higher oxidizing agent and will therefore be reduced. So, therefore, Ag is the cathode, as reduction takes place at the cathode. And this would mean that the electrons flow from the anode to the cathode, which would be from Cd to Ag. So our answer would be B. Question 1.10. An electrolytic cell is set up to electroplate an iron rod with nickel as shown in the diagram below. Consider the following statements. The iron rod is the negative electrode. The metal ions in the solution undergo reduction. The anode is pure nickel. Which of the above statements is true? So, since we want to plate the iron rod, we want reduction to happen at the iron rod. And reduction happens at the cathode, which is the negative electrode. So we know I is correct. The metal ions in the solution undergo reduction would also be correct, as we want the nickel ions in the solution to be plated onto the iron rod. And then, obviously, if the iron rod is the cathode, the anode has to be pure nickel. So all 3 are correct. So our answer is D. And that's all for this video. Thank you. Hi guys, today we're going to be looking at a question on organic compounds. The letters A to H in the table below represent organic compounds. Question 2.1. Write down the letter that represents each of the following. 2.1.1. An alcohol. So, if we look at our, is this 8 different compounds, we know that an alcohol must have an OH group. And as you can see, some of them just have the condensed formula. But if you draw them out, you should be able to see that D would then be the alcohol. Question 2.1.2. A compound with a formal group. So a formal group is usually present in aldehydes. And if we look at all our structures, we can see that A is an aldehyde. Therefore, A is a compound with a formal group. Question 2.1.3. An unsaturated compound. So unsaturated compounds are compounds that have 2 or more double bonds or triple bonds between carbon atoms. And if we look at the compounds given, we can see that compound E has a triple bond between these C atoms. Therefore, the unsaturated compound is E. Question 2.2. Write down the IUPAC name of compound B. So compound B is this compound over here. And if we find the longest continuous carbon chain, which would be this chain over here, we can see that we have 6 carbon atoms. Therefore, this is hexane, as we all only have single bonds. On the hexane, we have 2 methyl groups. Here's one and here's the other. We also have 2 bromine atoms. And in order to have the lowest numbering, we would start the first carbon over here. Our name would then be 3,3-dibromo 4,4-dimethylhexane. Question 2.2.2. The name of the IUPAC name of E. So as we have said, E has a triple bond between the carbon atoms. We can see that we have 1, 2, 3, 4, 5 carbon atoms on the main chain. And since it has a triple bond, it is pentene. We then also have 2 methyl groups, which are indicated here. And we always start counting from the side closest to the double bond. Therefore, it would be this side over here, as the double bond is between the second and the third carbon atoms. We would then have our 2 methyl groups on the 4th carbon. So our name would be 4,4-dimethylpent-2E. Question 2.3. 2 different compounds in the table above are functional isomers. Define the term functional isomers. So a functional isomer is compounds that have the same molecular formula but have different functional groups and therefore belong to different homologous series. Question 2.3.2. Write down the letters that represent these functional isomers. So if we look at all the organic compounds that we have, we can see that A is an aldehyde, as we have the double bonded O on the first carbon. From the name, we can see that B is a ketone. And ketones and aldehydes have essentially 2 different functional groups, but it is just in a different position. So aldehydes have it either on the first or the last carbon, whereas ketones can have it anywhere in the middle carbons, just not the first one or the last one. Therefore, our 2 functional isomers would be C and A. Question 2.4. Compound F is formed when carboxylic acid reacts with another organic compound X in the presence of a catalyst. Write down the name or formula of the catalyst. So compound F, as we can see here, if we look at the condensed formula, we can determine that this is an ester. And an ester is formed when a carboxylic acid reacts with an alcohol. And the catalyst needed for this process, which is known as esterification, is H2SO4. And as I've just mentioned, this type of reaction is esterification. Question 2.4.3, the structural formula of compound F. So here we have our condensed formula, and we want to determine the structural formula. We can see that we have 2 carbon atoms, and then the 2 oxygen atoms, and then another 3 carbon atoms. So our structural formula will look something like this. Question 2.4.4. The IUPAC name of compound X. So compound X would be the alcohol part of the carboxylic acid. And in this case, it would have 3 carbon atoms and have the OH group on the first carbon atom. Therefore, this compound would be propan-1-ol. And that's all for this video. Thank you. Hi guys, today we're going to be looking at a question on vapor pressure of different organic compounds. The vapor pressures of different organic compounds are determined at 20 degrees Celsius. The vapor pressures of compound A, B, and C are not shown in the table. Question 3.1. define the term vapor pressure. So vapor pressure is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. Question 3.2. The vapor pressures of compound A, B, and C are given in random order below. Question 3.2.1. Write down the vapor pressure of compound C. Compound C we can see is 2,2-dimethylpropane. Therefore, it has more branches than compound A and compound B. This will cause it to have the lowest boiling point, as it has the smallest surface area, and small surface area means a lower boiling point. And since boiling point and vapor pressure are inversely proportional, compound C will have the highest vapor pressure. Therefore, it would be 146 kilopascals. Question 3.2.2. Explain your answer to question 3.2.1. So, as we've said, compound C has more branches than compound A and compound B, and it has a shorter main chain length, being propane, whereas compound B and C have butane and pentane. It therefore has a smaller surface area, and due to this, compound C has the weakest intermolecular forces between A, B, and C. Therefore, less energy is needed to overcome these intermolecular forces than the energy needed for compound A and compound B, resulting in the highest vapor pressure. Question 3.3. Compounds D and E are compared. Question 3.3.1. Which compound has a lower boiling point? So, as we have said, boiling point and vapor pressure are inversely proportional. So the one with the higher vapor pressure will have the lower boiling point. Therefore, compound E will have the lower boiling point, as it has the higher vapor pressure between D and E. Question 3.3.2. Fully explain the difference in vapor pressure between compounds D and E. So, compound D is propanoic acid. Therefore, it has hydrogen bonding, dipole-dipole forces, and London forces in its molecule. Whereas compound E, being butanol, has dipole-dipole forces and London forces only. This means that the intermolecular forces for compound D are a lot stronger than the intermolecular forces for compound E. Compound D then requires more energy in order to overcome or break the intermolecular forces, resulting in the boiling point being higher and the vapor pressure being lower. And that's all for this video. Thank you. Hi guys, today we're going to look at a question on organic reactions. Study the flow diagram below. Reaction 1 is a cracking reaction forming two organic compounds, W and T, as the only products. Question 4.1. Define the term cracking reaction. So a cracking reaction is the chemical process in which longer chain hydrocarbons are broken down into shorter, more useful molecules. Question 4.2. Is the product in reaction 2 a primary, secondary, or tertiary haloalkane? Give a reason for your answer. So here we have reaction 2 and it forms bromobutane. The bromine is joined to the first carbon atom. Therefore, this carbon atom is only joined to one other carbon atom, making this a primary haloalkane. Question 4.3. Write down the structural formula of compound W. So compound W is the other compound with T that is broken down during the cracking reaction. And we know that compound W goes through reaction 2 to form bromobutane. Therefore, the organic compound W has 4 carbon atoms. And since it has no double bonds in reaction 2, therefore it is just butane. Question 4.3.2. The molecular formula of compound U. So, compound U is compound T and compound W before they went through the cracking reaction. Therefore, in total, we have 8 carbon atoms, 4 from compound W and 4 from compound T, and we have 18 hydrogen atoms, 10 from compound W and 8 from compound T. Our molecular formula is then C8H18. Question 4.4. For reaction 2, 4.4.1, give the name or formula of the inorganic reactant. So, for reaction 2, we go from organic compound W, which is butane, and we get to bromobutane. Therefore, this is halogenation. And the inorganic reactant would be Br2. Question 4.4.2. The type of reaction. choose from substitution, addition, or elimination. So since this is halogenation and we are removing one H atom to replace it with a bromine atom, this is then substitution. Question 4.4.3. One reaction condition. So the reaction of halogenation requires light, or alternatively, you could say heat. The flow diagram on page 9 is redrawn below for easy reference. So this is the same diagram we had in the previous slide. Question 4.5. Write down the type of elimination in reaction 3. In reaction 3, we go from a haloalkane to organic compound R. Organic compound R then can go back to organic compound S through reaction 4, and reaction 5 brings it back all the way to an alkene. Therefore, our elimination reaction, which will form organic compound R, would be dehydrohalogenation. Question 4.6. Compounds R and T are positional isomers. The inorganic reagents shown below are available for reactions 4 and 5. Write down, question 4.6.1, the balanced equation for reaction 4 using structural formulae and the correct inorganic reagent shown above. So reaction 4 and 5 together should take us from compound R, which is an alkene, all the way to compound T, which is back to an alkene. Therefore, reaction 4 is hydrohalogenation, which is the opposite of reaction 3. So our structural formula will be our 4 carbon atoms, a double bond between 2 and 3 due to the removing the bromine and the hydrogen. Then we can just fill the rest of the hydrogen atoms. And then we want to add hydrogen bromide. And we then get, since our double bond was between the first and second carbon atom, the double bond will break and the bromine atom will be added to the carbon with the least hydrogen atoms, therefore carbon 2. So our bromine would be here. And this would be the structural formula for the reaction. Question 4.6.2. The balanced equation for reaction 5 using structural formulae and the correct reagent shown above. So to go from our haloalkane back to an alkene, we need to add NaOH. Therefore, our inorganic reagent will be NaOH. So we will go from our end compound plus NaOH, and it will result in the alkene, the double bond being added, where the hydrogen and the bromine are removed. And then we would have on the side as well NaBr as the sodium joins with the bromine, and we would have an H2O molecule. Question 4.6.3. The IUPAC name of compound T. So compound T, as we can see, has 4 carbon atoms and 8 hydrogen atoms. Therefore, it is butene. And since we know from the question before, the structure we have just got, the double bond is between the first and second carbon atom. But alternatively, you could have had it between the second and third atom. So either way, you could say but1-ene, or you could have but2-ene. And that's all for this video. Thank you. Hi guys, today we're going to be looking at a question on reaction rates. The reaction between pure aluminium and excess hydrochloric acid is used to investigate the factors that affect the rate of reaction. The balanced equation for the reaction is, and this being the balanced equation. Question 5.1.1. Define the term reaction rate. So reaction rate is the change in concentration of products or reactants per unit time. Experiment 1. In this experiment, 1 mole per decimeter cubed hydrochloric solution, acid solution, reacts with 0.5 grams of aluminium strip from an aluminium roll at room temperature. The graph of volume of H2 versus time for this experiment, not drawn to scale, is shown below. Question 5.1.2. For the time interval T is equal to 0 to T is equal to 5 minutes, the average reaction rate for the formation of H2 is 0.033 decimeters cubed per minute. Calculate the mass of Al present in the container at T is equal to 5 minutes. Take the molar gas volume as 24.5 decimeters per mole. So since we have the rate and we have the change in time, we can calculate the change in volume of H2. So in this case, we have our rate being 0.033, change in volume over 5 being our time. We then get our volume to be 0.165 decimeters cubed. Now that we have our volume and we have a molar gas volume, we can calculate the moles of H2 produced. And if we plug all of this into the calculator, we should get 6.74 times 10 to the negative 3 moles. We then look at our formula and figure out the mole ratio between H2 and Al. So for every 2 moles of Al, we have 3 moles of H2. So we can say that the moles of Al is equal to 2 over 3 moles of H2. We then take 2 over 3 and we multiply it by the moles that we have just calculated. And when we plug all of that into the calculator, we should get 4.49 times 10 to the negative 3 moles. We then can calculate the mass of Al. As we know, mass is equal to moles times molar mass. And we have the moles being 4.49 times 10 to the negative 3. And we have a molar mass of 27. We then get our mass to be 0.12 grams. And that's how many grams reacted total in the whole reaction. We then take our initial mass that we have of being 0.5 and we minus the amount that reacted and we get 0.38 grams. And that is how much of Al is remaining in the container after 5 minutes. Assume that the concentration of HCl stays constant for the duration of the reaction. Question 5.1.3. Use the collision theory to explain the change in reaction rate from T0 to T5. So here we can say that the surface area or the size of the aluminium decreases, causing less particles to be exposed. This results in less effective collisions taking place per unit time, causing the reaction rate to decrease. Experiment 2. Experiment 1 is repeated using a 2 mole per decimeter cubed hydrochloric acid solution. Question 5.1.4. Redraw the above graph. No numerical values needed to be shown in your answer book and label the curve A. On the same set of axes, draw the curve that will be obtained for experiment 2. Label this curve B. So we already have this curve being A, though you will redraw it in your answer book and label it A. And B, since we have a higher concentration of hydrochloric acid, it will still start at 0 and it will still end at the same point. However, the reaction rate will be a little bit quicker. Therefore, this graph will be B. Experiment 3. Experiment 1 is repeated using 0.5 grams of pure powdered aluminium. Question 5.1.5. How will the volume of H2 produced in experiment 3 compare to that of experiment 1? Choose from greater than, less than, or equal to. The reaction rate will still be, the volume of H2 produced will still be equal to that of experiment 1, as it is still the same amount of Al used. However, since it is powdered Al, the reaction rate will just be slightly quicker, but the amount of H2 gas produced would still be the same. Therefore, it is equal to. Question 5.2. Curve X is a Maxwell-Boltzmann distribution curve for a reaction under set reaction conditions. A change was made to one of the reaction conditions to obtain curve Y. Question 5.2.1. What change was made to obtain curve Y? So, curve Y has more particles that have a higher kinetic energy. Therefore, the change made is that the temperature increased. Question 5.2.2. Give a reason for the answer to question 5.2.1. So, as we have said, curve Y has the maximum at a higher kinetic energy, therefore the peak shifted to the right. This means that the average kinetic energy of the particles increased. And that's all for this video. Thank you. Hi guys, today we're going to be looking at a question on chemical equilibrium, the reaction of carbon monoxide gas with oxygen gas. is investigated. The reaction reaches equilibrium in a closed container at constant temperature T degrees Celsius, according to the balanced equation. Changes to the conditions at equilibrium are made at different times. The graph shows the results obtained. X, Y, and Z represent the gases in the above reaction. Question 6.1.1. Define the term chemical equilibrium. So chemical equilibrium is when the rate of the forward reaction is equal to the rate of the reverse reaction. Use the graph to answer the questions below. Question 6.1.2. At T1, oxygen was added to the container. Write down the letter that represents O2. Choose from X, Y, or Z. So at X we can see T1, the concentration increases with a large spike, whereas in Y and Z, Z it decreases gradually and Y it increases gradually. Therefore, X represents O2 due to the sudden increase, which is the oxygen being added. Question 6.1.3. At T2, the pressure is adjusted by changing the volume of the container. Was the pressure increased or decreased? At T2, we see there's a sudden drop in the concentration of Z. There's a gradual drop. There's a sudden drop and then a gradual drop of Y, and a sudden drop, then a small increase in the concentration of X. Therefore, due to O2 being the X graph, and it has a sudden drop and therefore it slowly increases, we know that the reverse reaction is favored. And when the reverse reaction is favored and it has more moles, as we have 2 plus 1 instead of just 2, it means that the pressure was decreased. Question 6.1.4. Give a reason to answer in question 6.1.3. So, as we saw, the concentration of all the gases decreased and the reverse reaction was favored. Question 6.1.5. Write down the name or formula of the gas that is represented by letter Z. So since we know that X is O2, and from T1 to T2, the concentration of O2 decreases, which means that products are being formed, and the concentration of Z also decreases, that means that Z must be CO, so carbon monoxide. Question 6.1.6. Give a reason for your answer for question 6.1.5. So, as we have said, the concentration of Z decreased with a decrease in the concentration of X, which is O2. Question 6.1.7. What change in temperature was made at T3? Choose between increased or decreased. So, as we can see, our total reaction is exothermic. And at T3, the concentration of Z and X, which are both reactants, decrease, and the concentration of Y increases. Therefore, the forward reaction is favored, and a decrease in temperature favors an exothermic reaction. Therefore, the temperature decreased. Question 6.1.8. Use Le Chatelier's principle to explain the answer to question 6.1.7. So, we can say that the concentration of the products, in this case Y, increases, whereas the concentration of the reactants, being X and Z, decrease. This means that the forward reaction is favored. And since the forward reaction is exothermic, the temperature decreased, as a decrease in temperature favors the exothermic reaction. Question 6.2. Carbon monoxide gas reacts with water vapor at T degrees Celsius. The reaction reaches chemical equilibrium according to the balanced equation. Initially, 0.6 moles of carbon monoxide, 0.6 moles of water, and 0.1 moles of carbon dioxide gas, and 0.1 moles of hydrogen gas were mixed in a sealed 2 decimeter cubed flask. If the equilibrium constant Kc for this reaction at T degrees Celsius is 4, calculate the mass of carbon monoxide present in the flask at equilibrium. So to do this, we can start by drawing our table with initial moles, change in moles, final moles, and then equilibrium concentration. We then have CO, H2O, CO2, and H2. We know the initial moles of CO is 0.6. The initial moles of H2O is also 0.6. Initial moles of carbon dioxide 0.1 and 0.1 for hydrogen gas as well. We don't know the change in each, But since they all have a ratio of 1 to 1, we can just call all of them X. We then can say that our changes, since these two are reactants and these two are products, our final moles will be 0.6 minus X for the reactants and 0.1 plus X for the products. We then know that we can calculate our concentration, as we know our volume is 2 decimeters cubed. We can now write our Kc equation, being the products over the reactants. We know our Kc value is 4, and we can then add in our concentrations, which is 0.1 plus X over 2. And since the CO2 and H2 have the same concentration, we can square that. And then we have our concentration of the reactants, which is also the same, so we can square that too. And then when we rearrange and calculate X, we get X to be equal to 0.37 moles. We then can calculate the amount of moles of CO present at equilibrium. And this would be the total amount of moles minus how much reacted in the in the reaction. And we get 0.23 moles. We then can calculate the mass of the CO2 at equilibrium using mass of CO at equilibrium is equal to the moles times the molar mass. We have our moles being 0.23 and the molar mass of CO is 28. If we plug all of that into the calculator, we get 6.44 grams. And that's all for this video. Thank you. Hi guys, today we're going to be looking at a question on acids and bases. Hydrated potassium carbonate, this is the formula, is a weak base. A solution is prepared by dissolving some of the solid in water. Question 7.1. Define the term weak base. A weak base dissociates partially in water in order to form a low concentration of hydroxide ions. Question 7.2. Write down the formula of the conjugate acid of the carbonate ion. So the carbonate ion is a base, and in this case, a base is a proton acceptor. Therefore, when it forms a conjugate acid, it will then become HCO3-. And this, since it's an ion, it's in an aqueous solution. A hydrochloric acid solution of concentration 0.1 moles per decimeter cubed is titrated with the prepared potassium carbonate solution of unknown concentration. The balanced equation for the reaction is, this is the equation. The results of the titration are given below. Question 7.3. Determine the value of P. So to get the value of P, we need to take the initial reading plus the volume used in order to get the final reading on the burette. So if we say 20.05 plus 6.5, we get 26.55 centimeters cubed. For Q, since we want the initial reading and we have the final reading and the volume used, we can take the final reading minus the volume used, and our answer would be 28.15 centimeters cubed. Question 7.4. Methyl orange is used as an indicator. Explain why methyl orange is the most suitable indicator for this titration by referring to the pH at the equivalence point. So, as we know, potassium carbonate is a weak acid. It's a weak base, and hydrochloric acid is a strong acid. Therefore, the titration endpoint will be less than 7, as it is a strong acid reacting with a weak base, making the solution acidic at its equivalence point. Question 7.5. Calculate the concentration of potassium carbonate solution. So to do that, since we have the mole ratio and we have the volume of each substance used, we can use the formula, the concentration of A times the volume of A over the concentration of B times the volume of B is equal to the moles of A over the moles of B. We then know the concentration of A, we can make the hydrochloric acid, is 0.1, and the volume used is 25 centimeters cubed. The concentration of B, which is the unknown, times the volume, and then to get the volume, we would add these two together and get the average between them, which would be 20.1 is equal to the moles of A, which is 2, over the moles of B, which is 1. And if we plug all of that into the calculator and rearrange to calculate the concentration of B, we should get 0.0622 moles per decimeter cubed. And that is equal to the concentration of potassium carbonate. I'm going to do the last question on a new slide so there's more space to work out. The above potassium carbonate solution used in the titration was prepared by completely dissolving 6.525 grams of hydrated potassium carbonate in 600 centimeters cubed of water. Question 7.6. Calculate the value of X in the formula. So this is a question on water crystallization. So we first need to calculate the concentration, and we can do that using the mass times the molar mass times the volume. We have our concentration, which we calculated to be 0.0622. We have the mass being 6.525. We want to calculate the molar mass, and we have our volume being 0.6 as it's centimeters cubed, and we want to convert to decimeters cubed. If we then rearrange and solve for the molar mass, we get the molar mass to be equal to 174,84 grams per mole. And this is the molar mass of the K2CO3XH2O. We then determine the molar mass of the potassium carbonate portion, which is 2 times 39, which is for the potassium, plus 12 for the carbon, plus 3 times 16 for the oxygen, plus X times 18, as 18 would be for the whole water molecule. We then equate this to the total molar mass, and when we solve for X, we get X to be equal to 2. And that's all for this video. Thank you. Hi guys. Today we're going to be looking at a question on redox reactions. Dilute hydrochloric acid reacts with magnesium at 25 degrees Celsius according to the following balanced equation. Question 8.1.1. Use oxidation numbers for each of the reactants and explain why this reaction is a redox reaction. So we can start with the oxidation number of Mg. So Mg starts off as a solid, therefore it has an oxidation number of 0. And in the product it forms magnesium chloride, therefore it has an oxidation number of +2 in order to balance out the 2 chlorine atoms. The hydrogen, on the other hand, the HCl, the hydrogen has an oxidation number of +1 in order to balance out the chlorine ion. And then in the products, it forms H2 gas having an oxidation number of 0. Therefore, this is a redox reaction because the oxidation number of H changes from +1 to 0, and the oxidation number of Mg changes from 0 to +2. Question 8.1.2. Write down the formula of the oxidizing agent in this reaction. So the oxidizing agent is the substance that is reduced. And as we can see, the HCl is reduced as it gains an electron and becomes H2. Therefore, you can say that H+, as it is the hydrogen ion, or you could say HCl is the oxidizing agent. It is observed that dilute hydrochloric acid does not react with copper at 25 degrees Celsius. Question 8.1.3. Explain this observation by referring to relative strengths of the reducing agents. Since copper is a weaker reducing agent than hydrogen, the copper will not reduce the hydrogen ions in order to form H2. Therefore, they do not react. Question 8.1.4. Will dilute nitric acid react with copper at 25 degrees Celsius? Choose from yes or no. Explain the answer in terms of relative strengths of the oxidizing agents. So, if we look at our redox reaction table, we can see that the nitrate ion, so nitric acid, is a stronger oxidizing agent than copper 2+, the copper ion. Therefore, it will cause the copper to be oxidized. Therefore, a reaction will take place. Question 8.2. A galvanic cell is represented by the following cell notation. Question 8.2.1. Write down the balanced net ionic equation for this cell. So, the balanced net ionic equation, we start with lead solid, so Pb solid, and we add the Fe3 plus ions. We then form the lead ions and the iron 2 plus ions. And when we look at this, it's not really balanced as we have 2 lead ions and 3 over here. Therefore, in order to balance it, we put a 2 in front of both of the ions. A stronger reducing agent is now used with the same oxidizing agent under the same conditions. Question 8.2.2. How will this affect the initial EMF of the cell? Choose from increase, decrease, or no effect. If a stronger reducing agent is used but the same oxidizing agent, since reduction happens at the cathode and the EMF of the cell is the cathode minus the anode, and our cathode's EMF is higher, it will result in the total EMF of the cell increasing. Therefore, our answer is increase. And that's all for this video. Thank you. Hi guys, today we'll be looking at a question on redox reactions. A strip of silver is added to a 1 mole per decimeter cube solution of PbNO3 at 25 degrees Celsius. Consider the reaction below. So here's our reaction. By means of calculation, determine whether this reaction is spontaneous or non-spontaneous. So in order to determine this, we need to calculate what the EMF of the cell is. And the EMF of the cell is equal to the reduction minus the oxidation. As we can see, the Ag is oxidized and the Pb is reduced. Therefore, we can look at our reduction table and get the EMF. We can get the voltage values for these two half cell reactions, and we get our reduction voltage to be negative 0.13, and we minus our oxidation voltage, which ends up being 0.80. And when we calculate all of this, we get negative 0.93 volts. Therefore, our reaction is non-spontaneous as we have a negative EMF. Question 9.2. The simplified diagram below represents an electrolytic cell. The electrodes are made of carbon. Question 9.2.1. Define an electrolyte. An electrolyte is a substance of which the aqueous solution contains ions. Question 9.2.2. Write down the predominant oxidation half reaction that takes place in the cell. So as we can see, we have concentrated sodium chloride and we have 2 carbon electrodes. If we look at sodium and chlorine on our redox reaction table, we will see that chlorine is a higher reducing agent. Therefore, it will be oxidized, causing our half cell reaction to be 2Cl minus, making Cl plus 2 electrons. Question 9.2.3. Write down the names or formulae of the products formed at electrode Q. So due to this being an aqueous solution, it obviously contains water. So when the chlorine ions then form chlorine on the electrode, the sodium ions will join to the hydroxide ions and will form sodium hydroxide. Or alternatively, you could have just said hydroxide ions. And then with the remaining H that's in the water molecule, it will form hydrogen gas, which will be released. Question 9.2.4. Explain the answer to question 9.2.3 by referring to the relative strengths of the oxidizing agents involved. So if we look at our redox reaction table, water is a stronger oxidizing agent than the sodium ions. Therefore, the water molecules will be reduced. And that's all for this video. Thank you.